Okay, class, this is section 11.4. There are two conjectures in this section. We are only going to deal with one of them in this video. This is an investigation for conjecture 94. We are going to do this investigation by hand in class tomorrow. So right now what we're going to do is do it on Sketchpad. So I need you to open up Sketchpad and we are going to create similar triangles. So you can put me on pause as you create your similar triangles and open up your Sketchpad and get it going. Remember, for two triangles to be similar, they have to have all corresponding angles congruent and the sides in the same proportion. So I believe the easiest way to do that is to make two equilateral triangles, because you know all equilateral triangles have to have 60-degree angles. So you know the angles will be congruent. And then we can make sure that the sides are proportion that we want. Like we can set it so that it's double or a third or 2 times or 3 times. So you can see that I've just made 2 circles to make my equilateral triangles, and now I've made the intersecting point there. So I am going to construct segments there to make my equilateral triangle. Then I can highlight the circles and hide them. And then I'm going to make another equilateral triangle right next to it. So I'm going to make my circle and then go from that point back to the center of the first one. Find the intersection point and then construct the segments. Now, remember how you constructed the circle. This point down here will change the length of the sides if I drag this point because of the way I constructed it. So I can make that as big or small. I could also use this one and drag that point. That's the only one that you'll be able to drag to change the size. So I'm going to hide these circles, and then we're going to make the lengths so that it's a nice ratio between the two similar triangles. So I'm going to highlight the length of each one of them. Let's see, let's make this one to maybe we can shrink this one just a little bit. Oops, I had it. To put it right at 4 so that the first triangle is twice as large as the second one. It's not cooperating with me. Doesn't have to be exact, but it'll make it nicer when we do the ratios. If we can make it exact. And I can't get it to do it exactly. There we go. Okay, so there's our 2 similar triangles. So now what we're going to do is we are going to construct medians. So I'm going to highlight this segment and construct the midpoint. And then I'll highlight this point and construct the segment. Then I'm going to do the same thing with my smaller triangle. So I want to construct the midpoint and then construct a segment. If you remember, the definition of a median is the length from any vertex to the midpoint of the side opposite. So now what I'm going to do is measure these two medians. Now I'm going to set up my ratio of these two triangles. So if I go to number, calculate, my little calculator will come up. So I am going to do larger triangle divided by smaller triangle always. So I'm going to highlight length AB and I'm going to divide it by length CD, which we already know what that is going to be. And if you notice on my calculator, it was a little bit more than that, but it rounds to 2. So there's my common ratio. Now, if I put this length AE, I'm going to kind of do it by triangles here. So I've got larger triangle, smaller triangle. I'm going to put the length of EA, which is my median, underneath AB, and then put FC, which is my median of the smaller triangle, and just kind of stack them here. So now I'm going to go back to my calculator, and this time I'm going to highlight my median of my larger triangle and divide it by the length of my median of the smaller triangle. And look what I get. It is in the same ratio as the ratio of the sides. Okay, pretty neat. Okay, so in this case, because they're equilateral triangles, my medians happen to be the same as my altitudes. So length AE is not only a median, but it's also the altitude, just because they are equilateral triangles. The next thing I want to look at are angle bisectors. So I'm going to hide my medians. And now I'm going to construct an angle bisector. So I'm going to highlight angle B. And then I'm going to say construct angle bisector. Well, it went right through point D. I don't want the whole segment. So what I'm going to do is highlight or get the point that is on both those segments, and then make that just a line segment. So I'm going to construct it as a segment, and then I can hide this line. Hide the bisector. So I just have a segment, just like that. Now I'm going to do the same thing over here. So I'm going to highlight point vertex D and construct an angle bisector. Now I need to find that intersection point where it hits the opposite side. I'm going to highlight both points and say construct a segment, and then hide the actual bisector. Okay, now I'm going to measure those lengths to see if they are also in the same ratio as the lengths of the sides of my similar triangles. So I'm going to highlight those two. I'm going to say measure lengths, and here they are. So I am going to put, looks like DH over here under this list, and then I am going to put GB here. Notice they're the same. So my angle bisector, because I'm with equilateral triangles again, are the same length. So guess what the ratio is going to be? It is also going to be 2. I am going to screenshot this and make sure that it's in our notes. and I want you to fill in the conjecture. Not sure why all those lines appeared, so let's try that again. Let's see if that worked a little bit nicer. A little bit. I think we can see it. So if we go back to our conjecture, proportional parts conjecture, if two triangles are similar, so that's what we started with, our two equilateral triangles that were similar with the ratio of 2 to 1, then the lengths of this corresponding blank, blank, and blank are blank to the lengths of the corresponding sides. See if you can't fill in the blanks with the correct responses. I do want to mark this photo for you to make sure that you have the right information so that we could remember that these two are angle bisectors. These two were medians. And actually, all of them are altitudes. Okay, I'll see you in class tomorrow.